Hello dear children, today we are going to discuss class 10th 6th chapter triangles. This is very important topic and most twisted bits are coming from this last year paper also coming from these similar figures. Similar figures means if two or more figures have same shape but not same size. If two or more figures have same shape but not same size. Here see circles I am giving. Even two or more circles also same way. Radius is different. That means radii is different for two diagrams. Squares here there. Two squares are its sides are different but shape is same. For equilateral triangle sides are unequal, sides not equal but shape is same, equilateral triangle. And line segment also length is different but those are similar figures. But last year question paper, which of the following is not similar, they have asked. In that circles, squares, line segments, triangles given. For equilateral triangles only those are similar. For triangles not, because all triangles are not same shape and size. Only for equilateral triangle this shape will be equal. That's why that is the answer. Only triangle answer is given. So many members did a mistake that one. Congruent figures you have learnt in 9th level. If two or more figures have same shape and size also, both shape and size are equal, then those are congruent figures. Here two triangles I have drawn approximately, but one is blurred. One boundary is I have drawn very blur in manner, but both in same shape as well as size. Here squares are there which are also equal in shape and also size. Triangles also both are same. This is called congruent figures. If two triangles are similar, then their corresponding angles are same and the corresponding sides ratio are equal. Here see, very important. For two similar figures, this is the important content in our chapter. It is very important, most important content. Okay, based on this all the sums will be explained. So if two triangles, see these two triangles are similar, okay, then their corresponding angles means angle A, angle D both are same. Here angle B, angle E is same, angle C is equal to angle F, both are same. And AB by DE, that means sides ratio I am writing. AB length I am showing the with pen, the length is AB by DE. BC by EF, AC by this one last side, AC by DF is equal to certain length, certain value will be there, that is ratio K. Say name it as K. If K is greater than 1, that means it will be big figure coming, magnified or big figure when comparing with second one. If K is less than 1, that means numerator is less when comparing with denominator. By the time K is less than 1, small figures will come. Diminished figure when comparing with left to right, it will be small coming. If K is equal to 1, both are equal. That means congruent figures are coming. So this is very important. Here similar figures means its sides ratio are equal. Sides ratio but not lengths. Its sides ratio only equal. See what I am drawing. For that only I have left that like this. See here how I am giving only single curved line I drawn, that is angle A is equal to angle D. Here angles are equal. Angle B is equal to angle E. Angle C is equal to angle F. Corresponding angles are equal and corresponding sides ratio are equal. So many contents are removed, but very important theorems kept in our syllabus. That is BPT, basic proportionality theorem. BPT theorem means basic proportionality theorem. It was another name, yes, Thales theorem also. Its another name is Thales theorem. Generally, theorems are proved statement given, required to prove, construction, proof. That is the order of explanation. So first of all, statement also in the examination they may not give. Directly we should write statement also. They'll give write and prove basic proportionality theorem or Thales theorem. They will give like that question. From there onwards we need to understand statement means that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Here up to comma, that is hypothesis, are given. The comma after sentence is we need to prove. That means RTP, required to prove. R to prove you can write. Here the given triangle is ABC is a given triangle. Say DE parallel to BC. DE parallel to BC. By this time in triangle ABC DE parallel to BC. RTP means AD by DB is equal to AE by EC. AE length by EC length. This is RTP. Construction, join BE comma CD. Little bit it is tough theorem. So and draw DM perpendicular to AC. Here DM is there, that is perpendicular to AC. That means 90 degrees from there onwards it is present. Again EN perpendicular to EN, this is EN perpendicular to another side AB. Now we are going to discuss proof. You know that area of triangle means half into BH. That means half into base into height. That is important thing. In that proof we are going to discuss area of triangle ADE. Upside one triangle is there, you know, see once. ADE. In this condition, one side you take, this side you take AD as base. Half into AD into EN is perpendicular this side. Means that height it is EN. Half into AD into EN. Next, that is area of ADE, you know. Next, downside BDE, one triangle is there. You might have observed from the figure. BDE. Triangle BDE means half into downside. Just you think it as base BD, downside. Okay, its height is exterior, outside it is present, that is EN. For obtuse angle triangles, height will be outside, so that is EN. Half into DB into EN. Now area of triangle ADE by C. One simply you can write it as area of triangle this by this, area of ADE by area of BD, you write half into AD into EN by half into dB into En. Here En cancel, half of cancel. Area of ADE, see, area of ADE by area of BDE, area of triangle BDE is equal to AD by DB, because remaining values are cancelled, so that this is the remaining value. Now the next content is another triangle. We have to observe from the figure. Area of triangle ADE by BDE, area of triangle BDE we got AD by DB, that is say 1, equation 1, say it is equation 1. Area of triangle ADE, upside triangle only, ADE, another side you take AE, another side means towards AC side, you observe, towards AC side you observe. Just I am going to observe with yes, showing the figure. Based on that, the explanation will be, you can observe very clearly. This side ADE observe. AE is base, half into AE into, here its perpendicular is DM. This side perpendicular is there, so that is height DM. So area of triangle ADE from this side onwards, AE base half into AE into height DM. Now DEC, another triangle is there in between two parallels. You might have observed this is a parallel lines in between DEC, another triangle is there. Its area is half into, say this is base half into EC, and height is outside it is present because it is an obtuse angle, that's why DM is a perpendicular, outside is there. Now area of triangle ADE by area of triangle DEC is equal to ENC. In this condition, next occasion is area of triangle ADE is equal to half into AE into DM, because which is perpendicular outside, for obtuse angle triangle outside it will be present. I have shown area of triangle DEC is equal to half into EC into DM. Now this by this you do, that means area of triangle ADE by area of triangle DEC you do, half cancel, and this will be, I adjusted directly, so AE by EC will be remaining, because this by this means divided by DM by DM cancel, half cancel, AE by EC will be present. This is, you can, if you want, you can write one extra step as like previous, you can write. This is 2. Next one is triangle BDE. See, triangle BDE and DEC are on the same base DE and between the same parallel BC and DE. So therefore area of BDE and area of triangle DEC are same. That is third one. From 1, 2, 3, AD by DB is equal to AE by EC we got. This is the basic proportionality theorem, but you need to practice while you are writing. Time you may not understand, after practicing you will get that. This is very important theorem. Based on this, so many sums are there in the 6th chapter. From this, another one is also there, that is converse of BPT. Suppose one triangle ABC is there, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. This is the statement. So given AD by DB is equal to AE by EC. Then we need to prove DE parallel to BC. We need to prove DE parallel to BC. Say, for this proof I am going to tell, let us assume DE is not parallel to BC. Say DE dash parallel to BC. I have drawn with dotted line in the figure. So it is observed as it is not a parallel to BC. Obviously we know that. But we need to prove by theorems. So by deduction we are going to write. Let us assume means contrary to DE. That means disprove theorem we are going to give. DE parallel to BC actually as per our observation from the figure. But you say DE dash parallel to BC. By this time AD by DB is equal to AE dash by E dash C by previous theorem BPT, basic proportionality theorem. But AD by DB is equal to AE by EC, that is given. Given means hypothesis in the question itself given. AD by DB is equal to AE by EC. These two are equal. AD by DB equal here. So we should equate both sides, right sides from the two equations. AE dash is equal to AE by EC. AE dash by E dash C is equal to AE by EC we should write. Left hand side, down side I wrote AE by EC. Now AE dash is equal to E dash C. Add 1 on both sides. Add 1 on both sides. What you will get? AE by EC plus 1 is equal to AE dash by E dash C plus 1. AE plus EC, suppose you are doing LCM, AE by EC, AE plus EC coming, because here LCM EC only, AE plus EC by EC. Here AE dash plus E dash C by EC. Here LCM is E dash C. Now AC by EC, because the length value will be AC total value coming. AC by E dash coming. Based on the figure you can observe and you will get that. Because here AE plus EC means AC only. AE dash plus E dash C means AC only. AC get cancelled, in between is equal to is present. So 1 by EC is equal to 1 by E dash C. Now reciprocal it. EC is equal to E dash C. That means never be equal like this. E dash must be coincide with E. Therefore DE parallel to BC only, because our assumption is wrong, because DE dash is not parallel to DE. That means E dash is coincide with E, no. That's why DE only parallel to BC. Hence proved. This is the converse of BPT. Converse of BPT. If you want to write hence proved also you can write. This is very important content. So need to practice and write it in a one page and practice it. Just I shall keep for some time to write the entire data. See the next page I am keeping for writing for some, yes, for some time I am holding the entire material. Yes, basic proportionality theorem. This is the next page. Just you write it entire at a one page. You can understand each and every content. Just go through that. If it is not clearly, yes, based on my voice you can write also. That is given one number, just I rubbed, that's why I kept some papers to cover that. Just with black pen, no, I wrote, no, that's why it is rubbing. So make it write very clearly later. This is third page. From here onwards, write the continuation of BPT. Here some part is present. Later converse of BPT theorem that you write. It is also in another page. It is present. So up to there I am keeping for some time. Copy it. It is very very important theorems. Both these theorems only present. Remaining syllabus is removed. Old syllabus not kept as it is. Just they have removed. Very important theorems only kept. So basics of these, so many sums will be given. So need to draw the diagrams also. With pencil you draw very nice diagrams. So you can write easily. The next page. This is the next content. Last converse BPT of last content. So this is the last introduction parts of the 10th standard given. All the chapters I have kept. So better to write in one place and practice it. In A4 sheet, suppose you are writing means you will get entire information. From the first and second chapters I kept sums also. You can watch in my videos. If you watching means please subscribe, so it is supportive for me. Subscribe and like it and share to your friends so that they can write easily. All the children, have a nice day children. Thank you.